Welcome to the Midwest here. We're looking at some toy train transformers. I was having some difficulty with some of my components, not quite responding correctly in the lower voltage ranges of these new electronic transformers. So I decided to take a look and see if there might be some kind of a concern I really had. I have the older type, Variac type, and I went ahead and replaced one of these electronic devices with the old transformer Variac, and problems went away. So I'm going to show you what I think may have been the problem. What you're seeing now on the screen is an oscilloscope display of the voltage that is present at the output of one of these electronic transformers, the newer ones. Now, the electronic transformers have devices inside, electronic controls, that actually allow voltage to pass through to the components. They act as gates. So as you adjust the handle, rotary handle on the side of the top, you adjust the amount of voltage that is allowed through to the component. And here's a visual of how it works. I'm rotating the handle on the side of the transformer. As you can see, some points we're getting some unusual, these are like a ramp function, and even though the RMS value 13 volts, which is RMS is equivalent to, it's called the DC voltage, which is the heating equivalent of DC is volts RMS. Now mathematically that's just fine, but there are components out there in the real world that do distinguish between a nice, smooth, fully powered sine wave and the waveforms that you see on the screen. So right now that shows about 30% of the handle has been of the output voltage. Now this, as I go back to where it says 0, there's still some voltage applied, so 1.7 volts. Down here you can see it's 10 volts per division, and every one of these divisions, these major divisions here, is 10 volts. The other aspect, this is 20 milliseconds, 2 milliseconds per division, and that's each one of these divisions. And when I get the voltage up high enough to where the meter can read it, and we see that it's 60 hertz, 59.9, whatever. So I was having a problem when I was operating some of my components in this range from 0 to about 30% on the meter. After that, the problem seemed to go away. Now, this is the full scale. This is 100% of the output of the transformer. You still do not get complete sine waves. Now this, I'm holding my pointer here, is 0 volts. That point is where, if we were lying across the scope, the oscilloscope, at that level, that would be 0 volts and no power. So for this period of time, and this period of time, there's actually no power applied. Again, the volts RMS are correct. That is what the power applied is, but the component itself may have some difficulty when it comes into an area where there is no power and then is required to respond, and it doesn't necessarily act smoothly. So I really think this was the problem I was having in the lower ranges, is the this waveform, and the components were not designed to see this type of waveform, but rather a full sine wave. So I hope that helps others. If you're having a problem, especially at the lower ranges, lower voltage ranges, maybe you want to try one of the older variac type transformers and see if it cures your problem. Hope this helps.